So this is one of the concentration terms which we study in class 11th and 12th altogether. So let's see what it is. So molarity, it is defined as the number of moles of solute present in per liter of the solution. Per liter of the solution. Per liter of the solution. Okay, so what it does, it tells about the quantity of solute present in 1 liter of the solution in terms of moles. Okay, so we can write, since it is denoted by capital M, so we can write its formula as the number of moles and number of moles of solute upon volume of solution in liter. Volume of solution, and this volume of solution should be in liter. Okay, so from here we can say that the unit of molarity will be what? Number of moles of solute means mole, we write it as MOL upon liter. Okay, or we can write it as mole liter inverse, or we also call it as molar. Okay, and denoted by capital M. Okay, so now the next thing is let's talk about the moles. Okay, so what is mole? What is mole? So mole is the measuring unit, we can say, for chemists. And it is same as, means we can say it is equals to 6.022 10 raised to the power 23 number of particles, and these particles can be electrons, protons, neutrons, atoms, molecules, or any other entity. If you are saying 1 mole, that means we have this much number of particles. Okay, so the mole can also be related with the mass of a substance, the number of particles, as well as with the volume in case of gases. So I can say that if you want to find the number of moles and you have given weight or mass of a substance, then you can write it as the given mass of the substance. Here in this case it can be a solute, so given mass upon molar mass. Second thing, the same thing, if suppose a number of particles are given to you, so you can write it as given number of particles divided by Avogadro's number, which is 6.022 10 raised to the power 23. Or if suppose we have a gas and its volume is given at STP, so given volume at STP upon molar volume at STP. I should write it first like molar volume at STP, and this molar volume at STP, it is equal to 22.4 liters. Okay, so by this way, whatever the information will be given to us in the question, according to that information we can find out the number of moles, and by using this number of moles and the volume we can find out the molarity. Okay, so in case of molarity we have different cases. Suppose we need to find the molarity of, or molarity after dilution. Molarity after dilution. molarity after dilution. What is this case? Suppose we have a solution. Suppose this solution has molarity M1, it has volume suppose V1, and number of moles suppose it has N1. Okay, so dilution means adding solvent to a system, so we are diluting it. Since we are diluting it, what changes will come to this solution? Let's see here. This molarity, for sure it will change, volume will change, but we are not doing anything to the solute. Therefore the number of moles, because the number of moles are for solute, therefore the number of moles will remain the same. Okay, so for this solution, for solution 1, if I use the relation of molarity is M1 here, number of moles N1, and volume of solution is V1. From here, if I try to find out the value of N1, which is the number of moles, then I'll get M1 V1. Okay, similarly here, after dilution, if I apply the same formula, M2 equals to N1 upon V2, I'll get N1 equals to M2 V2. From here, if I equalize both the relations, what I'll get M1 V1 equals to M2 V2. So this is our molarity equation. This is called molarity equation, and this molarity equation can be used. This is molarity equation, and this molarity equation can be used if we have diluted the solution. Okay, if we have added the solvent only, then in that case we can find out the molarity after dilution. Okay, this M2 is the molarity after dilution, M1 is the molarity before the dilution. Okay, so thank you.